what if? What if I told you that the universe isn't a place that we simply work up in, but a habit that we formed?
That is a very specific and I'd say slightly unsettling way to put it, but
Yeah.
yeah, yes. It captures the spirit of what we're covering today.
It just gives me this bit of vertigo. We usually think of the laws of physics as the absolute bedrock, gravity, electromagnetism.
The flow of time itself.
Exactly. We just assume they were laid down at the Big Bang, structure formed on top of them, and then billions of years later, we showed up to, take notes on how it all works.
That's the standard narrative. Laws come first, reality second, and observers are a distant third. It's a comfortable hierarchy.
Right. But the stack of research we're diving into today, specifically this work on cosmogony and what it calls Pre Noetherian Physics, it flips that stack completely upside down.
It really does.
It proposes that the laws didn't come first. The laws are actually the result of us looking.
It's a radical inversion. The core argument here is that symmetry, this sort of raw, chaotic potential of the universe that comes first, structure only emerges because an observer performs a specific action.
And the source material calls this action slicing.
Slicing, yes.
It creates this mental image of a chef's knife just cutting through reality. But our mission today is to figure out if that's really what's happening. We're going to unpack how the act of observation might literally create causality, create time.
And create the very laws of physics, all out of this infinite potential. It moves physics from studying what is out there to studying how we filter what's out there.
Right.
And honestly, once you start to see it this way, it's hard to unsee.
So let's start at the absolute bottom, or I guess the background. The source material refers to the fundamental state of reality as the void. Now, my brain immediately goes to outer space, or a vacuum. Just empty, cold nothingness.
And that is the first trap. In this specific framework, the void is definitely not nothing. It's actually the complete opposite.
It's everything.
All at once, it's an overload. Precisely. Technically, the source defines the void as an infinite-dimensional Hilbert space.
Okay, that's a mouthful.
It is, yeah. But we don't need to get bogged down in the linear algebra. Think of it this way. Imagine a library that contains not just every book ever written, but every book that could be written.
Okay, so Hamlet is in there, but so is Hamlet with one typo, and Hamlet written entirely in emojis.
Exactly. And every random combination of letters that makes zero sense. It's all in there.
This is what the text calls perfect epistemic symmetry.
Every possible state, every possible history.
Every possible future, all existing in a perfect state of superposition.
So it's infinite potential. But if everything is there simultaneously, isn't that just static, white noise?
That's the paradox of the void. Because it contains everything, it effectively contains nothing distinguishable. You can't point to something and say, this happened before that.
Because there's no order.
There's no internal order. It has no time. Because time requires a sequence, a before and an after.
Right. And causality requires separation. To say A caused B, A has to be distinct from B. But in the void, A and B are just smeared together in this infinite overlap.
So the void isn't before time in a chronological sense.
No, it's beneath description.
I like your analogy of white noise. White noise technically contains every frequency, every song, every speech ever recorded. But because they're all playing at the same volume, you don't hear a symphony. You just hear the hiss.
That is a perfect analogy. The void is that hiss. It's the maximized entropy of information. So the question becomes, how do we get from that infinite causeless soup to, well, to us, sitting here, having a structured conversation?
We need to tune the radio. We need to pick a frequency.
We need a primitive action, and the source material calls this the slice.
This is the observation part. But the text is really careful to distinguish this from just, human eyes looking at things.
Correct. Don't think of it as biological vision. Think of a slice as a mathematical cut into that infinite Hilbert space. It acts as a filter. It breaks that perfect, overwhelming symmetry of the void.
And forces it into a specific perspective.
Exactly.
So if the void is the library of all possible books, the slice is the act of choosing one specific book to read.
Or maybe even more fundamental. It's choosing the language you're going to read in. When you slice, you're setting up the rules of the game. You select a basis.
What counts as an object?
You select a metric.
How you measure distance between them.
And you select an update rule, how those objects change.
And the claim is that before the slice, those things, distance, objects change, they don't even exist.
Not in any meaningful way. They're all potential, not actual. And here's the part that usually trips people up. Time itself is a result of the slice.
Yeah, I circled this phrase in the notes, time is slice internal structure. That feels heavy.
It's the difference between the river and the map, right?
Mm.
We usually feel like time is this river carrying us all along. But this theory suggests time is just the page numbers inside the specific book you pulled off the shelf.
So the page numbers don't exist out on the shelf. They only exist inside the book.
Precisely. If you took a different slice, pulled a different book, you'd have a different timeline, a different definition of now.
Wow.
Time isn't a background stage that we walk onto. It's a feature of the lens we're looking through.
Okay, that actually helps. It's like a movie reel. The whole movie exists all at once on the reel. That's the void. But time only happens when you run it through the projector.
That's the slice.
That's the slice.
Beautifully put. And this implies that simultaneity, what is happening right now everywhere else, is purely defined by how you've chosen to slice the universe.
Okay, so we have the void, which is everything and nothing, and we have the slice, which is the filter. This brings us to the inversion you mentioned, Pre Noetherian Physics. Now, I know enough about physics to know that Emmy Noether is a legend.
An absolute titan. In the early 20th century, she gave us Noether's theorem. It basically proved that for every symmetry in nature, there is a corresponding conservation law.
Give me the classic example just so we're all on the same page.
Okay, translation symmetry. If I do an experiment here, and then I move my equipment 5 feet to the left and do it again, the results are the same.
The laws of physics don't care about your absolute location.
Right. And Noether proved that because of that indifference, that symmetry, we get the conservation of momentum.
Okay.
Or if the laws of physics don't change between today and tomorrow, that's time translation symmetry, we get conservation of energy. Standard physics says, here are the laws. The laws have symmetries, therefore we have conservation.
It flows top down. Laws, symmetry, conservation.
But this cosmogony flips it. He says, no, you start with the void, then you slice, and then you ask a really simple question. What keeps this slice stable?
Because if the slice wasn't stable, it would just dissolve back into the white noise.
Exactly. A slice needs to be self-consistent to persist. It can't contradict itself. So we look for that stability, and that stability looks like a conservation law to the observer inside the slice.
This is the pre-Noetherian logic. We don't have conservation of momentum because Newton wrote it down on a piece of paper.
No.
We have it because our specific way of viewing reality, our slice, doesn't care where we put the 0 point on the ruler.
Yes. Conservation is just the slice, admitting that there is a direction where nothing changes. It's an artifact of the stability of our perspective.
That makes the laws of physics feel less like commandments from God and more like survivor bias.
That's a brilliant way to put it, yes.
The laws of physics are just the rules that didn't break when we started looking.
Precisely. Physics becomes the study of what remains stable when you filter the infinite. If a slice wasn't consistent, if the rules changed randomly every time you blinked, you wouldn't be a coherent observer. You wouldn't exist to ask the question.
So we are trapped in a stable slice because if we weren't, we wouldn't be we. That's logic. That feels like a trap, but I can't find the exit.
It's a self-reinforcing loop. Existence requires stability, and stability appears to us as laws.
Now, this implies something huge. If the laws of physics are just the result of a specific slice, and there are infinite ways to slice the void,
then there isn't just one set of physics.
Right.
Correct. The source material refers to this as a multiverse of physics. Not just different planets or different histories, but completely different operating systems for reality.
The text actually takes us on a tour of a few of these, which I think we should walk through because they really illustrate how geometry turns into matter.
Let's do it. It's the best way to visualize the theory.
Okay, stop one. The standard model slice. This is home turf.
This is us. It's defined by a 4-dimensional space-time, 3 dimensions of space, 1 of time. And it's governed by something called the Poincaré group of symmetries.
Which essentially just means we can rotate, move, and boost our speed without breaking the universe.
Right. And because this specific slice is stable in those specific ways, we get the specific suite of laws we know and love. Electromagnetism, the weak and strong nuclear forces, gravity.
These aren't universal truths. They're the fingerprints of the standard model slice.
That's the argument.
But then the source introduces the Aurelium slice. And this is where my brain started to cramp up. It talks about a 6-plane topology.
This is a theoretical slice, but it helps explain concepts you often find in, like, string theory. Imagine a universe that isn't 4-dimensional, but 6-dimensional. You have your normal 3 big dimensions, but then you have 3 compact dimensions.
Compact as in tiny.
Tiny and curled up on themselves. Think of a garden hose. From far away, it just looks like a 1D line, right?
Yeah.
But if you're an ant crawling on it, you realize there's a second dimension, that little circle around the tube.
Okay, so the beryllium slice has these tiny hidden loops at every single point in space.
Exactly. And here is the magic trick. In our world, momentum is just movement. But in the beryllium slice, if a particle has momentum inside those tiny curled-up dimensions, we, the big observers, we can't see it
We
moving.
just see it sitting there.
We see it sitting there, but it has this intrinsic property that comes from that hidden motion. And in this slice, that compact momentum manifests as electric charge.
Wait, so charge positive and negative isn't just some magical sticker on an electron, it's movement in a direction we can't point to.
In this particular slice, yes, it creates what's called a Kaluza-Klein tower of particles. It shows that what we call matter or forces are really just consequences of the geometry we've sliced into.
That turns things into relations. An electron isn't a thing, it's a way of moving through a specific slice.
Exactly. It demystifies the whole zoo of particles. They're just different vibrational modes of the geometry.
Then there was the quantum Hall slice. Now, unlike beryllium, this one is based on real experiments, right? The kind we do in labs.
Yes. This is the quantum Hall effect. When you trap electrons in a 2D sheet at near absolute zero and you hit them with a massive magnetic field, standard physics starts to get weird.
How so?
The normal translation symmetries, they break down. You can't just slide things around anymore in the same way. The laws in this subslice, they stop being about geometry, distances, and angles and start being about topology,
Yay.
specifically holes and winding numbers. The conservation laws here aren't about energy or momentum in the traditional sense. They're about topological conservation. We measure them in what are called Chern numbers.
I looked this up. It's like the difference between a coffee mug and a donut. Topologically, they're the same because they both have one hole.
Right.
But a bowling ball is different, 0 holes.
Exactly. In the quantum Hall slice, the physics is robust against messy details. You can dent the donut, stretch it, twist it. The physics stays the same. You only break the conservation law if you rip a new hole in it.
It really drives home the idea that a subslice, a specific experimental setup, can effectively run its own local constitution of physics.
Its own little pocket universe. It proves that laws can be local ordinances, not necessarily universal constants.
And finally, the text mentions the general relativity slice, Einstein's world.
This is the most complex one. In the other slices, the stage space and time was a fixed background. But in general relativity, the metric itself, the geometry, is dynamic. It curves, it warps.
And this leads to the infamous problem of time.
It's a famous headache in physics, yeah. If space and time are warping and stretching, you lose your external clock. There is no master timekeeper on the wall.
So time only emerges. How?
It only emerges from the correlations between matter and the geometry.
So if nothing interacts, time effectively stops.
In a sense, it reinforces that first point we made. Time is not fundamental. It is a local internal feature of the relationships inside the slice.
It's not the tick-tock of the universe.
It's the tick-tock of the matter within the universe.
We've toured the multiverse, but we have to land on the philosophical core of this paper. The source material uses a phrase that sounds like a post-rock album title, the ache of the void.
It is poetic, but it's referring to a very rigorous ontological trade-off.
The trade-off between being everything and being something.
Exactly. Remember, the void is infinite potential, perfect symmetry,
Yeah.
total freedom. But it's also nothing specific. To exist, to be someone.
It's a slice.
You have to cut away the infinity. You have to limit yourself. The text calls this being exiled from the void.
And this changes how I feel about those conservation laws we talked about earlier.
How so?
Well, usually conservation laws feel like safety rails. Energy cannot be created or destroyed. It's comforting. It means reality won't just glitch out of existence. But in this light, conservation laws are. There are the bars on a cage.
That's the double-edged sword. Stability allows for coherence. It allows for life. If energy wasn't conserved, you just dissolve into a cloud of probability. But that same stability is a limitation. We can't access the infinite freedom of the void anymore.
We're bound.
We are bound by the consistency of our slice.
So every law of physics is basically a scar left by our separation from the infinite.
That is a beautiful, if slightly melancholic, interpretation. Reality is the tension between the void and the slice. We sort of ache for the infinite, but we can only exist in the finite.
It brings up the question of the observer again, this participatory ontology. Are we just standing outside the fishbowl looking in?
No, and that's the crucial part. If we were outside, we'd be back in the void. And we wouldn't exist as distinct entities. The observer is a subslice.
We're inside the fishbowl.
We are a fluctuation within the void that has achieved enough internal coherence, enough stability to look at itself.
We are the void looking at itself through a cracked lens.
Through a structured lens, yes. The observer isn't an intruder. It's the mechanism by which the void becomes legible to itself.
That circles back to the anthropic principle, the idea that the universe is the way it is because we are here to see it. But this feels more aggressive than that.
It is.
It's not just that we are here. It's that our existence requires these laws.
Pre Noetherian logic again. Symmetry equals stability equals existence. You don't create the laws by wishing for them. You create them by the very fact that you are coherent enough to ask the question in the first place.
If the laws weren't there, I wouldn't be stable enough to be confused by them.
Bingo.
This has been heavy, but strangely clarifying. Let's try to summarize this map we've drawn.
Sure. We started with the void, the infinite structureless potential, the white noise of reality.
Then we introduced the slice, the act of observation or filtering that breaks that symmetry and creates distinction.
We saw how that slice must be stable to persist. And that stability creates symmetry, which manifests to us as the laws of physics and conservation.
We took a tour of the multiverse standard model, Aurelium Quantum Hall, proving that different slices create different particles, different rules, and even different definitions of time.
And finally, we acknowledged the cost, the ache. The fact that to exist is to be limited, to be separated from the infinite potential of the void.
Physics, in this view, isn't just discovering what was already there. As the source says, it's cartography.
It's mapping which slices are stable enough to hold observers. You aren't just an ant walking on a stage. You are the geometry experiencing itself.
Okay, here's the thought I want to leave our listeners with today. The source material ended with this really provocative idea that reality is the relation between the void and all possible slices.
The ultimate multiverse.
Exactly. If observing a slice creates the reality of that slice, and if there are infinite ways to slice the void, are there other stable, consistent slices right next to ours?
You mean overlapping with us?
Right here, right now. We're sitting in this room, tuned to the standard model frequency. But is there another observer inhabiting the exact same void, but sliced at a slightly different angle? Are they witnessing a universe with 6 dimensions and silicon-based life walking right through us like ghosts because our metrics don't interact?
If the Pre Noetherian view is right, the void is certainly big enough for all of them. There's no reason to think we're the only station on the radio.
That is something I'm going to be thinking about every time I walk down a quiet street. Thank you for helping me break my brain today.
Always a pleasure to slice the void with you.
And thank you for listening to the deep dive. Keep looking closely. You never know what structure you're creating. We'll see you next time.